We can hear you, Hilson. Yeah.
Okay. So yeah, so today I'll be a trainer for basic introduction to Google Earth Engine, and yeah, and so I'll start with the presentation, and later we'll do a hands-on session. So everything I prepared today we'll do parallelly. So if there is any complication, then we'll try to solve that in the way. So first, let me share my screen. Okay, so I think most of you are already familiar with the Google Earth Engine platform, but even if you do not have previous experiences, we'll still start from the very basic. So it will be easy to catch. So why we need a cloud computing environment? So let's start first from there, because from the last decade only we know that the supply of geographical information from satellite-based and ground-based sensors are rapidly expanding, and we need so we are already entered into a big data era, and hence we need to emphasize more on international collaboration, data-intensive analysis, and we need huge computing resources for high-end visualization. So when we are talking about the global, I mean, visualizing the changes in the global scale, then we need more computing power. And this is where the advantage of Google Earth Engine really shines. So why we, so the one of the main issue with processing in the local computing environment is that it becomes really inefficient to download the data, and also processing at a very large scale is really ineffective. So there is this quote from Jim Gray, who was working with the Microsoft. Often it turns out to be more efficient to move the question than to move the data. So instead of every time when you want to calculate, let's say, a vegetation, see the vegetation of environment at a particular place, you have to download the data and do some processing over it. But instead, if you can just transfer your requirement to some remote server, and it does some kind of processing and returns you just what you need, it is more effective way of utilizing the data set. So even when we do cloud processing today through Google Earth Engine, you will start to notice that processing through the cloud is just transferring our requirement to the cloud, and it does all the processing and gives you back data. You'll really start to feel how optimized the whole workflow becomes if we utilize this approach. So uh, this is the overall overview of using Google Earth Engine. So we have JavaScript and Python API to start with, and the default environment of Google Earth Engine is using the JavaScript API. So basically, if you know programming in JavaScript, then you can give some prompt, and the console it will send the your requirement to the cloud environment, and then hence it will utilize the data set which is already available in Google Earth Engine. uh, and there are also some functions like this algorithmic primitives that we call that can run in their server, and hence you will get the result in the end. So you do not need to know what is the internal implementation of algorithms, or let's say how the Google organizes all the computing clusters in the backend. So you just have to know what is your requirement and what request you have to pass uh, what request you have to pass to get that result. So in the backend, there is large amount of computing cluster or distributed computing cluster in Google Earth Engine, and this is utilizing the Google Cloud infrastructure, and we do not have to know any infrastructural detail, the implementation detail in the backend. Yeah, so the one of the major advantage of using Google Earth Engine is that it uses the 40 plus years of remote sensing data. So it has a massive archive of data set, and most of the data set that we commonly use, like open data set like Landsat and Sentinel, MODIS, terrain data set, example from SRTM, GTOPO, or other land cover data set and atmospheric data set are readily available. So you can just import the data set and start working with it. So talking about the amount of data that we have in Earth Engine, we have more than 200 public data sets. Now I think the number is increased to up to I think more than 800 public data sets are already available. more than 5 million images and 7 petabytes of data are being ingested every day, and more than 50 yeah, and 4,000 new images are ingested every single day in Google Earth Engine platform. So today we are going to see all of utilizing some of these functions, and these are some special geospatial primitives, some of the functions and data types that we use in Google Earth Engine. We'll discuss about all these data types in detail, and we'll also apply some of the functions like reducers, and in the coming days we'll also use some machine learning and some kernel operations over the over our geospatial data. So this is to give an overview of geospatial data type that is already available and data processing functions available in Google Earth Engine. So okay, so for the today's session we have some material in as a PDF. So we'll just follow that material, and for that you need to go to this link, this bit.ly link, and you will have access to today's material. And similarly, we'll use Google Collaborative environment. So we'll not use our local environment because setting up everything takes time, and we are going to perform all the analysis in Python, and hence this collab notebook will become really handy tool. So let me know if you can access this data. So it will redirect you to this link. Yeah, I've also shared this link in the chat, so it becomes easier to find there. Can you please let me know if you can access this material or not? Anyone from FAO side, can you access this link? Okay.
Yes, we have access to this site. That's
Okay, so this is the total overall table of content that we are going to work today. So initially we'll start with working with images, and we'll load the image from image collection, and we'll do some image metadata analysis, and try to visualize the images, and also try to create different color composites like true color composites, false color composite, and all those things, and how to upload our own geotiff data. We'll also see that. In the second step, we'll work with the image collection. So these are two different concept, image and image collection. And here we'll try to load image collection data from the Google Cloud, Google Earth Engine archive. So the data that is already available there, and we'll try to filter the image collection using different filtering methods, and some of the operations on image collections like image mosaicing and running mapping function over the image collection. And in the third part we'll look into mathematical operations like how to do a thresholding, and also do complex implement complex algorithms or formula using the expression command. In the second last part we'll see more into exporting and Google Earth Engine dataset into NumPy array and geotiffs, and in the end we'll also see how we can do plotting. Yeah, so this is the brief overview of today's session. So today's format is we'll see the code in this PDF, and we'll try to copy it into our collaborative environment, collaborative notebook. So if you go to collab.google, the second link that I have shared, you can start a new notebook here. Okay. So this is a Jupyter notebook environment in Google server. So most of the packages are already available here. So we'll just use this environment. Okay. So today's format is we'll try to understand what this code is doing, and we'll just paste it and run it and try to see the visualization. Okay, can you follow up to this point? You can just raise your hand in Zoom. Okay, I can see some hand raised. Okay, so let me start with some theory. So as discussed earlier, Google Earth Engine is a platform for scientific analysis and visualization of geospatial dataset for academic, non-profit, business and government users. And those data are not used mainly due to large data and complicated nature of satellite data. So if the data is used, there is some challenge in accessing and also doing some analysis over it. So we use Google Earth Engine. And why Google Earth Engine? Because it has massive geospatial data archive, and it can do some faster analysis with cloud processing, and now the commercial access is also available. Yeah. So for initial setup, we have to run this command. So initially we try to import all the libraries that we are going to use in this notebook, and this import EE and import GEE map is this GE map is for visualization purpose, and this import EE is to import all the library of Earth Engine, and we have to perform the authentication. So yeah, what you can do, you can copy and paste it here, and in the first run you have to install the GEE map because it is not installed by default. So I'll uncomment it and you can click on run. So to run, you can just press shift and enter at the same time. So I think it is doing the installation of this gmap library. Okay, so if it asks you for to follow this notebook to access your Google credential, click on allow. uh, yeah, I think it is authenticated now. Try to run it again. Yeah, so the authentication, it says true, so it is authenticated. In the next step, we have to do this ee.initialize. So this is where most of you might face problem, because uh, before we just had to use this command called ee.initialize. ee.initialize, but now we also need to provide this project path, right? So to overcome that issue, what you can do is I have prepared some manual on how to authenticate, so you can follow this presentation here. So this is the additional step. So this is the recent change from Google side, so you have to follow this step. So let's say if I need to do ee.initialize, so because this is my project, right? So you'll not be able to access this. So in this place, you will have to replace it with your project. So for that, you can visit the presentation link. I'll share with you this URL also. You can access this presentation from here. Can you try? So the step is you have to go to this cloud console environment. First you go here. I can see one person here. Okay. And from here you can see in this top left is not found. I think you have to copy and paste the whole URL up to the end of the sharing. Okay, can you try with this? Okay, so I'll do it once and then you can also follow. So the screenshot is already available with the steps. So these are the 4 steps you have to do additionally now. So in the left, you have to select your project. It says I have selected GEAIT. And the second step, it says you have to go to API and services. So just go to API and services. And in the second slide, you have to click on API, enable API and services, which is available here. And then search for Google Earth Engine. So the link is here, console.cloud.google.com.
Hilton, be a bit slow and ask them if they are following you or not, okay?
Yeah, sure.
Because some of colleagues are quite new to this.
Okay, sure. Yeah, you can select the project from this URL. Okay, so everyone can access this console. Yeah, please give thumbs up if you can follow. So if you can access this presentation, I'll start again. So there is this link in this first slide. You just paste this link in your browser, and then you can see this cloud console environment will show up. And from in this left, you can select the project list. And just select one. We'll use this project in our Earth Engine. Okay, so if you can, if you have completed this step, can you give thumbs up in Zoom? Also, feel free to unmute if you have any issues. Yeah, the next step is to go to APIs and services here and enable API and services. Okay, so After this step, you have to search for Google Earth Engine API. Do that. This one, and then select this API. So in my case, it is already enabled, but in your case, it might not be. So instead of manage, there will be enable option, enable button. You just click on enable, and then it will be enabled. So if you face any issue, you can just drop in chat. You can see it. Okay.
Yeah, I reached there, but the issue is now I see visibility, public category, analytics, big data, climate, and all those things. And on the right, it says Google Earth Engine API, Google. Should I click on it or?
So can you click on Google Earth Engine? So does it look like this? Like this?
Yeah, now it comes enable. I clicked on enable.
Okay, so your project is available, project name is available in the top URL, project equals to, in this
My
part.
first project, it says.
Okay, so
API
this GEEAIT is what you need to copy in this, in your.
It's my first project, but it is empty.
Uh-huh.
And there is a search option. That's it.
Yeah, can you search it? So you have to search Google Earth Engine API.
No, okay, I did that, but let's Google Earth Engine API. Yeah, Google Earth Engine API, asset care, fugitive emissions. Okay,
Yeah.
clicked on Google Earth Engine APIs.
Yeah.
Manage.
No, so it's already enabled, right?
No, I enabled it. Yeah, in the previous step,
Okay.
I enabled it.
So your project
API.
name is available in the top. In my case, it is GEE-AIT.
Let me see yours. Manage Google Earth Engine API. Mine is a little bit different. GAIT, Google Cloud.
Yeah, so in your case, it might be different.
Yeah, it's
It will
my
be
first
different.
project. I selected that one.
Okay, so you just need to copy anything that is after this equals to sign, project name, and then you have to paste it here in the project equals to.
Okay.
Okay, if I click run, so now the initialization is complete. So this is the recent changes in the Google side. So we just had to figure
Sorry,
out.
could you do
Yeah.
the last step again? From where to copy the project name?
The
It's in
project name is
collaboration.
available in this URL here. Project equals to. So once you are in this enabled page, in the top you can see the project URL, project name.
Mine is too long, but it doesn't mention. Yeah, at the end, it's only project. That's it.
And project there
Equals
is no,
project.
okay, so you can also see it from, okay, here. If you go to this URL again, this first URL again, console.cloud.google.com. In the first page, you can also see this project ID.
It gives me an error, HTTP error.
Can you share your screen?
Okay, let me do it again. I don't know. Should I copy the equal also, or only the name after the equal?
Only the name after the equal. Yeah.
And should I remove the 1 minute, please?
So in the end, it will look something like this.
How will it look?
So in my project name was GEE-AIT.
Okay, project equal to this one, huh?
Yeah.
Mine is a little project equal to project. It's the same. I don't know. It's the same, but still
Okay.
it does not recognize maybe.
You can share your screen, Yusuf, with Hilton.
Sorry?
Hilton, he can share his
I must
screen
have
with you. and then you can note about the mistake.
Yeah, sure, sure. So can you share your screen? Okay. So yeah, can you go to this authenticating EE slide, presentation slide? Yeah, can you go to authenticating EE? So the presentation that I shared. Can you go to this Google Cloud environment, console.cloud.google.com? Okay, I have pasted the link in chat. Yeah, I'll share the screen once again so you can try to follow this. I think it should work. So first you go to console.cloud.google.com. So this URL, right? And when you go there, you will be able to see this page, right? And from here, select a project. You'll have to select which project you want to enable the extension. So in my case, I select this GEEAIT. Right? So I can see the project ID here also. So maybe you can also copy this one. It's fine. GEEAIT and then paste it here. So in your case, it will be different. So but we also need to make sure that auth engine extension is already enabled. So you have to go to API and services in this page, right? And from here you have to search, click on enable API and services. Don't search for here, enable API and services, and then here you can search for auth engine API. And when you click here, if it is already says this green sign with API enabled, you don't have to do anything. But if it says enable here, then you have to click on it and enable the API first. So if I go back now, so in this main console page, I can see this project ID. Yeah, you can copy this into here, and when you click on run, it should initialize. So you can also follow this step in this slide. So I have you have to first click on this project and go to API and services, and here click on enable API and services, and the next step is search for Google Earth Engine API, and inside there click on enable. Yeah, is anyone able to do this? Okay, I can see one. Any others? Or you can feel free to share your screen and if there
Wait,
is an issue.
wait for some colleague didn't done yet.
Yeah, sure.
Yeah, if they completed, I will. Excuse me, Hilson, the project name is different for everyone, or this will be same like Jet.
Sorry?
Project name, yeah, project ID is different for everyone, or it will be same for.
Yeah, it is different for everyone. Yeah.
Okay, got it.
Yeah.
So one of them asked to share their screen, Hilson, I think.
Let me see.
یوسفي صاحب ته سکرین دې شیر کا او مخې ته ځه او چې کوم ځای کې مشکل چې دی پوه شي صحیح ده یا بل هم قرار یو چی
Now should be able to share.
So requires country. So it's in which part?
Usually this authentication process, before it was very easy. Google has changed their policy, I think, just few days back.
Yeah. So if you can already run this initialize, you can drop chat here. Okay, I can see Sophie has already completed that. Anyone else? Because this is required. Without this step, we cannot move forward. If you have any issues, you can request to share your screen and then, yeah, you can try to solve that.
Hello, colleagues. I'm unable to proceed to the initialization. I would like to share my screen.
Yeah,
Could you
sure.
please allow me to share my screen and proceed?
Yeah, you are already co-host. I think you can share now.
Now I'm here.
So in the top, you can see, can you minimize this?
Okay.
Yeah. So in the top, you can see select a project, right?
Select a
Here.
project, yes.
Yeah, click there. And then click
Eh.
on, I think you need to create a new organization first.
Create a new project
Yeah,
here.
yeah, you can click there.
And then?
Okay, so click create.
Yes, I already clicked create. This one?
Yeah.
Okay.
So I think it will take some time to complete that. Okay,
To
so
view
now
the page,
click,
select.
Okay, so now this is
Okay.
first the project is created. Now you can go to API and services. In the left side, you
Okay.
can see
Okay.
yeah,
Okay. Here, enable.
enable. Yeah. Okay, enable in the top. Enable API and
Yes.
services.
Okay. Okay.
And then search for Google Earth Engine.
Google Earth Engine
Yeah.
API. Okay.
Click on this. And click
Enable.
on yeah. Right. So now if you click on the Google Cloud again in the top right left corner, yeah, Google Cloud, yeah, that one.
Mhm.
Just 1 second. Your project name, I think, yeah, it's not a little. Can you go up?
Mhm.
Just a second.
Click on the my project maybe 50694, that one.
Yeah, in the
This one.
Yes.
Mhm.
And then the project ID is this nodal hyphen pod, this one. Yes.
The whole.
Yes, all one copy.
Uh-huh.
And then go to the notebook.
Notebook.
Collab.
collab.
1 minute, please.
So I think you have to run the collab first. Yeah. You go to collab.google. So yeah, in the new tab, you can go to collab.google. So I'll paste the link here. Yes.
Mm-hmm.
New notebook. So we are going to work here, and from the PDF, you can copy the first authentication, import all the libraries. Yeah.
Okay. Okay.
Yeah. So this first red box up to the top. Yeah. Control C. Okay. So to run, you can click Shift and Enter.
Remove the number.
Yeah. Now it's fine. Shift and Enter. Or you can also click on this small play icon in the front of this box. Small play icon. In the
Here.
left, yeah, left, right, left, top left corner.
Mm-hmm.
Play icon.
Play icon in the left. A little bit in front of the play
Yeah.
icon, a little bit left. Yeah. You can use your cursor to go to that play icon. Small triangle.
That's okay. Vale. تاسو شايف بخير هستي؟
Yeah, or you can also
Vale,
click
تاسو
click Shift and then Enter.
Enter.
هو حسين خيل سيب. Manana زي او training کې مصروفه یم. So where should I click? Where should I put my cursor here?
So,
I mean
a bit left.
left.
Yeah. There is a
You
small
mean
circular icon, right? Play icon.
play icon? Oh, okay,
Yeah.
okay, play icon. Okay.
Yeah.
Uh-huh.
It should take a while. And the top left, you can also see code, right? Plus code.
Yes.
Click on that.
Insert code.
Yeah. So this is how you can add a new line. And
Okay.
the next step is to copy the next box. Sorry, from the
Okay.
PDF.
Okay.
From the
Let's go
PDF.
to the PDF. Yes. Here, this one.
Yeah. Yeah. Control V. Yeah. So just replace that project with
Okay. Let me go to the project. My project.
that one. Yes.
Oh, no.
No, only
No.
replace EE-Hilson part.
Within the
Okay.
single quotation, yeah.
Yeah.
Okay.
Control V, I think it's better. Now run it.
It's somewhere.
Warning, geochronicle entered here is reason. Permission denied.
Check. Can you check your project ID again?
Okay, here.
Yeah, can you click on my project 50694? There. Yeah.
Okay. Uh-huh.
This is the main piece. Can you check if the API is enabled again? API and services.
Not enabled.
Click there and search for Google or something. See?
It's
already
enabled.
This is the issue.
Click on manage, I believe. If you click on manage, then those things will appear. This one, yeah. Now the real project name will appear. Copy and paste this one into there, then it will work. Mine was the same issue.
Okay.
So where is the project name? ECP step?
Can you go down?
This one?
I think it
This
should be
one,
down.
this one, I think this one.
Yeah, that is the same actually. 50.
Can you go down a little bit?
Okay, all right. Scroll down.
Down there, go up.
Nothing.
غدا نوراني صاحب
Bale sir.
په دغه کې لږ مخکې لاړ شه د پاس براوزر د هغې کې چې ورکړی دی دلته سرچ کې او مخکې لاړ شه همداسې لاړ شه ځه مخ او کرسر سره همداسې اخري ځای
آخري cursor project نوم لیکل شوی دی خلاص.
نه ستا پروژیکټ تر اوسه نه دی کریټ شوی ښه ته کار همدغه پیج له سر نه اوپن کړه
پیج د سره نه اوپن.
او بیخي د سر نه تر راوشه صحیح شو همداسې کوم لینک راکړه هغه کاپي کړي
ښه.
Yeah, this one. Nodal code.
ته اوس لاړ شې او دې ته لاړ شه دا هغې ته
No, can you go back? You see the top. The name is in the top.
پاس هم دلته ستا کریکټ ده
Yeah, this nodal code. So you can see the project ID, right?
او همدغه د نوډل بس کنټرول سی
Yeah.
کړه
Same.
کاپی کا اوس راشم هغه ته نوټ همدا پروژیکټ So in
Honest has
fact,
mentioned that it may not have the GE registered, so I think that could also be issue. So
Can you click on this link visit something? Visit Google no, in the bottom.
Okay.
Go down. This one, HTTP developer Google Earth Engine guide access.
Where is it?
the link, yeah.
Visit, yeah, top of that. Okay, click on that. Google Earth Engine. First, register. I think register to the use Google Earth Engine. I think dismiss. Register to the use Google Earth Engine. Over here in the text. Register to use. Yeah. Go down. No, go down a little bit. In this.
Okay.
Yeah, click on that. This is has been registered for Google Earth Engine Cloud. This is the first time you use Google Earth Engine, right?
Yes.
So I think, can you just search in Google, just say Google Earth Engine one more time. Just go to Google, just search Google Earth Engine. Earth Engine. Okay, enter. Then click on the link. Yeah, perfect. Then go to the platform, the menu bar. Okay, code editor. Click on code editor. Okay, go in. This is the same email ID you're using.
Yes.
Perfect. Yeah, I want to register new project. Okay, click on this one. Unpaid one. Just use. Let's just leave as it is. That's academic research. That's fine. Yeah, go ahead. Academic research. Next. I think existing one is fine. Second one. Project. Wait a minute. This one, my project 50694. Click the. There's only just one, right? Just below. Third one.
There is no.
Oh no, my project 50694.
Oh, your project.
No. You just click on this down. There are three items in the menu, right? Just
There
click
is
the bottom
two
one.
item. There
There's
is
another
two
one.
item.
Second one. Yeah, just second one.
Okay.
Yeah, perfect. Okay, continue to summary. Okay, confirm. Wait a minute. Okay, now you go to the collab. Yes, other one, red color one. Next tab. Yes.
Okay.
Can you run that line again? Go up. Okay, run it again. Just this red color button. There's a red color button, right? Shift enter.
Yeah, this one.
Yeah. Perfect.
Okay.
Okay.
So just remember this project ID. So every time you run the Google Colab, Google Earth Engine, you have to use this project ID. So better to keep it in somewhere.
Okay.
Okay, so anyone else? Yeah, you can stop sharing your screen now.
All right.
Now we can go ahead, I believe.
Okay. Can you stop sharing your screen?
I did not stop.
No.
I did not stop. Oh,
No,
okay,
we
okay,
can
here,
see.
here. Okay, okay.
Okay, done.
Okay. Um, 1 second. Yeah, it's here. Okay, so the after you complete this initialization step, so we set up the map visualization parameter as a next step. So first, just make sure this is working up to this initialization, and yeah, let's just copy this map visual parameter and go to our notebook and paste it here. So there is more in the next box. Okay. So this map will be loaded if you just set up this map visualization parameter and initialize the map with this command. So I'll try to explain what this is. So this is using a gmap library. So it is a Python package for interactively interactively visualizing these maps in this Jupyter Notebook environment, and it is easy to work with. So if you go to the Cloud Console of Google Earth Engine, so you already have a visualization window over there, and you can perform some data inspection in the environment itself. But when it comes to this Earth Engine in Colab in Python environment, you do not have those capabilities. So that's why we use this gmap library. So you can first visualize it over this notebook only, and second, it also helps to translate the data from Earth Engine data type to a normal Python data type. So this is a quite flexible Python library we will use in this training session. So these are the different map parameters. So in the later section also we will use. So this wide is only giving it wide. Like if I change to 60%, for example, it will just change the wide of the map frame. And this is the center where the map will be centered. So it's near Iran and Afghanistan border, and a different zoom level you can also define here. Okay, so maybe I'll share this screen, so where I have already pasted all the data set, but what you can do is you can copy from the PDF file your code and then paste it, and then you can run. And if you face any issue when doing this process, you can just raise your hand and yeah, ask me. Okay. When you run up to this step, you will be able to see this map. So if you have completed this step, you can just let me know in the chat. Yeah, is it fine? Okay, so the next step is working with image. So this is our so here from here on we'll start working with the Earth Engine data type. So images are the raster data that, and all the raster data in Earth Engine are represented as image object. Okay, so images are composed of one or more band, and each band has its own name, data type, scale, mask, and projection. So as any other raster data type, it also has its name, data type, scale, mask, and projection. We have to note that. And each image has its metadata stored as a properties. So images are core building block of remote sensing imagery in Earth Engine. So there are two type of raster data set, that is image and image collection. So the fundamental unit is image, and the collection of image will form the image collection. So Yeah, so if you see in the presentation, I have also posted this link, Earth Engine data catalog. If you visit there, you will be able to see all different raster and raster data set in this catalog. So if you want to know in more detail, you can visit this link, and all the public archive of data set will be available here. So if you want, let's say, a land cover data set, you can search, and from the different providers, the land cover data set will be available here. Okay. Similarly, Landsat dataset, yes, but Landsat, MODIS, and Sentinel dataset can also be easily accessible from this top here. Okay. So today we are basically using this Landsat 8 surface reflectance data, this one, and the tier 1 is a collection of a high quality data set. So we go to this tier 1, and here you can see this is the code that you have to copy and paste to get the image collection. Okay, so this one also I have provided in notebook, but if you see this ID here, so this is the same because we are using the Landsat 8 data collection, but this here is the image ID, so I am only importing individual image here. So if I yeah, you can copy this from the presentation, sorry, PDF. This code block. So all the code block I have put in this red box here. So just copy this and you can run it. So now you can see the image is already loaded. So if I click on this, so the difference is that when you work with the Python, you can directly use the print option like this one, like here. Print hello world. So it will already print this data type, but since this is an Earth Engine object, you cannot directly use the print command. Okay? So you'll have to use the display, and this Earth Engine command, object will be rendered here. Okay, so if you see here, I have already loaded one Landsat scene from 2013, and this has all the information on number of band. Right? If I click on expand, you can see there are almost there are 19 band as list, and you can also see there are properties of the image. So in the next step, we are trying to do some calculations by using these band combinations, and also we'll try to filter the image based on the, let's say, cloud cover, so we can also learn how the filter operation is done. Okay, so this is the detail of the image. We'll try to see the image information and metadata next. So you can copy this code from here. So if you have any issues with this loading this image, Landsat image, yeah, let me know if you can follow up to this loading the image until the image is fine. Okay, so yeah, so the next step is image information and metadata. As I said that there are many properties and the metadata of this data, right? So when you copy this, so here I'll try to explain. So this image data is loaded into this image variable of a Python. So now you can see this image.band name will try to read its band names. Okay, read all the band within this image and assign to this band underscore name variable here. And next we are trying to visualize that list. Similarly, we are trying to see, so here in this image has a multiple bands, right? 19 band. So we just select one particular band and try to see its projection system. Okay, so basically we are trying to extract the metadata information from the data itself. So from image we are selecting a single band, and then from that we are taking the projection. So these are all the methods that is already available in Google Earth Engine Python API. So when we call this, so it will automatically return the projection and all band name information. So this is the scale of the data set. So projection dot nominal scale. So it is 30 meter per pixel. Yeah. So for this is for band 1 and this is for band 3. We are trying to compare between different bands. So if they have the same scale or not. So if you see here in the band name, if we display this, we can see there are 19 bands, right? This is the same information that we see here in the band, but only the name. So the band name is assigned as the first band is surface reflectance underscore B1 SRB2. So these are 19 bands, and the projection system is 32641, and its transformation parameters are also available, right? And in the third, we have printed the nominal scale. So for this band SRB1, so it is 30, and also for the band 3 it is 30. So in this way you can extract some metadata information from image. And if you want to see what are other metadata metadata properties available, you can also extract what are the available properties that you can use to filter the data. So if you see this, there are the list of this information that is available in those data set. This information you can also find in data catalog. So let's say if I go to this URL, and because now I'm using the Landsat image, and here Landsat 8 surface reflectance, and if you go to this image properties, you can see all the information here also, and this is the same information here. Okay, so the next step is to get the cloud cover information. So this cloud cover, if you go to here, it is represented by this cloud cover name in property name, and it gives percentage of cloud cover from 0 to 100%. So let's see, here it says 5.01. It means this particular image that we selected earlier has the cloud cover of 5.01% over the whole scene, which means it is relatively better. And the timestamp, you can also extract timestamp by using this image.get this function, and then it will give you the date and time, but it is giving in millisecond. And now you can extract this into ISO format by using ee_date.format. So if you do this, it will give you in normal date and time human readable format instead of this this Unix type. Instead of this millisecond format, you can get date and time in this format also. So this is like different ways of extracting different information and metadata information from image. So there are more you can also explore later, but in the next step we'll try to filter based on these properties. Yeah, can you follow up to this point? If there is any issue, please let me know.
Yeah, mine is okay with the cloud cover, but the rest it gives error. I don't know. The cloud cover is shown there, but the rest it gives error. Date is also the cloud cover, and then time step. These two are fine. Then it says name error, trace back most recent call last this.
So can you verify if it is the same? Sometimes also when you copy and paste, it can have some extra spaces which is not needed.
Possible. Yeah.
And so the other thing is make sure these two lines are commented out.
Which two lines? Sorry.
So before this display, there is this two line which is just to just for the like a documentation.
Excuse me, sir. We are until get a specific metadatabase properties. No, mine is get information about the bands is a list.
Yeah, this one, right?
Yeah, until here.
So this band 1 projection, can you get this data?
If I click on band 1.
Yeah, so if you click on this projection here, you will get all this detail. There is a small arrow in the left, right?
Yes, there is a band 1 projection, type projection, and EPSG.
Yeah, EPSG code. So this is the projection, the EPSG code for your projection system. Yeah.
Okay.
So the
And then
basically in this step we are trying to extract the metadata information from the image.
mhm.
So any error in this part?
No, until here I'm fine, but no, not get a list of all the metabase properties.
Yeah, you can once verify this code here.
Ilson, in the PDF, you don't have that code.
So this one.
Yeah.
Okay. Yeah,
Maybe
I'll just paste it in the comment section.
Mm-hmm.
You can use this one.
Yeah.
Get a list of meta. Okay. And then new code.
Okay, so yeah, I have added some more after preparing that the PDF. So if there is some code missing, just let me know. All right. So we move to the next step. Yeah, the next step is image visualization, because we only took the metadata, the text information from the image. So here, as I mentioned earlier, I will use the gmap library, and the map properties are set in this step. So the center, zoom level, and width, right? So all this throughout this notebook, I'm going to use the same center, zoom, and width level. That's why I already defined these properties in the first line, because I can reuse that property. So you can see here, zoom is set to 8%, width 40%, and center is near Afghanistan, here around the border. So this is the empty frame, but above this I am trying to load the image that we just this image. Yeah, so if you see here, first we trying to initialize the map. This is the basic map, and we add the layer over it. So this is the image layer, right? So image that we are using from previous step, and when you click on map, this map will be loaded. So if you click run, it will take a while to run, and yeah, here you can see this is the Landsat scene that we are using. It looks completely dark for now, because we have not changed the visualization property, but yeah, next step we'll change some visualization property, and we'll be able to retrieve the natural looking remote sensing image. Yeah, so have you completed this step? Yeah, okay. So the next step is true color visualization. So if you see here, I think I have to explain some more on this map item. So you can just drag pan. You can also draw some geometries over here, zoom in, zoom out, and if you see here in this setting on the right corner, you can change the map visualization parameter from this toolbar. So if you click setting, then there is these three stacks. Okay, so this layer 1 is the recently added layer. If you click on setting, yeah, from here you can change different band combinations. So currently it is taking band 1 as red, band 2 as RGB image, right? So it is red, green, and blue. Band 1, band 2, band 3. So it is a different combination. So if we change this, let's say band 4, band 3, and band 2, and if you click on apply, okay, so I think this is also a false color composite. So the true color composite is 432. Yeah. So you have to apply some stretch because the image in so if you see the image properties also before, this is unsigned integer 16, so it has a very wide range of values, from 0 to I think 64,000. So if we just limit the value to one standard deviation, so in mathematical term, if you just limit change this stretch value, then the contrast of image will improve. Okay, so initially it was very different, dark image, but when you change this band combination, it will produce a natural looking color. Yeah. So instead of going here and changing this every time, you can pass this into a visualization parameter. So let's say in this case I have used some stretch, right? But I can also use this min and max stretch. So as I mentioned, the data is ranging from 0 to something around 64,000. So I just limit it to 30,000 because the extreme is the data might not be useful. And the band combination is in order band 4, band 3 and band 2. Okay, and I've also given name Landsat 8 image, so it will not be layer 1 but Landsat 8 image next time. So you can click on drawn. So here you can see a true color Landsat image. Yeah, by default it is using 432 as passed here, and this param underscore L8 we are using here when we are adding the layer itself. So initially we did not pass anything in the add layer, just the image, and the image appeared by default dark like this. Okay. Yeah, can you follow up to this point? True color composite. If anyone have issue, then yeah, you can raise your hand. Okay, shall I move to the next step? Okay. So the next step is selecting single band from the image composite. So here, if you see, we have selected the combination of 3 different band, right? 4, 3, 2, and this image contains all the band, 19 band, but we can select the individual band from the image also. So I want to select NIR band, so we can use this function image.select and then pass the band name. This information is coming from the top here, from the list of band.
Yeah, can you paste that code? It's not in the PDF.
Okay. This one?
Yeah.
Right. So if you run this command, and you can see a single grayscale image. So this one is only band 5, which is the NIR image, not RGB but an NIR. So if you go to
It
the
shows
visual,
it
yeah.
shows an error.
Yeah, what does it say?
A name error.
Name,
Traceback most recent call last name error.
this one, right?
NIR single band is not defined.
Okay, so I think you did you miss this first line? Can you check?
No, I did not copy that. This first line is not available here in the chat box.
NIR. No. First you have to. Yeah, it is there in the first line. NIR single band equals to image.select.
Oh, okay. I missed that.
So just follow the step sequentially, because the image that we use here is coming from the previous step. So the difference between this previous image and this one here is that in this case we use the image composite. So we visualize using the 3 band, but it consists of all the 19 bands. But in this step we only selected a single band. So this visualization only contains 1 band and not all. Yeah, here you do not have an option to select the 3 different bands, right? To improve its contrast, you can select this stretch function and click on apply. Yeah. This way the image contrast will improve. Usually 2 to 3 standard deviations should be fine. Yeah. So if there is no issue in this step, then I have one exercise here. We can from the previous step. So what is the spacecraft ID for the image loaded above? So this one. So in this tutorial we'll try to follow all the exercise also. So if there is any issues working with this code, then you can follow the solution in the end, right? But I would suggest you to try yourself first, and if there is issue you can take a reference from the solution. So the property name is spacecraft ID. Okay. So if you see the properties name here, the list of properties earlier here, from here you can see station. It's a long list. Yeah, the spacecraft ID. So we are trying to filter using this, and we can also filter based on cloud cover, right? So yeah, we're trying to do this. Okay. So first one I'll do this here, so you can so if you use image.get, then you can filter from the metadata. So here we want to filter based on spacecraft ID underscore ID. So let's assign into some variable here, spacecraft ID, and if you want to display this, we can use display spacecraft ID, because this image.get spacecraft ID will assign its value to this variable here, SPC ID, and then we can display this information. So you can see this is a Landsat 8. The spacecraft ID is Landsat 8. So in this way you can also extract an individual image property. Yeah. So this next step I would like you to do, and here we are planning to create image visualization with 5-4-3 band combination. So as I said in this part here, so this is visualizing based on 432, which is RGB image combination, but we need 5, 4 and 3 combination. 5, 4 and 3. Yeah. So this will create a false color composite. So as a hint, you can use the same code block as this one, but you have to change some component of the visual parameter here. So this is not of a Google Earth Engine slide, but it is more of a visualization. Okay, let me copy this. Okay. You have to modify this band combination. So I think you have already figured out. So you want to integrate this infrared band also during visualization, and the first band will be band 5, band 4, band 3, right? So we have to make change here. 5, band 4, and then band 3 combination, and rename it to false color composite. Now the image looks different, right? So it is trying to highlight. So the concept of false color composite is that you will use image combination of RGB band, not in the order of RGB. So let's say the red channel is being mapped to red, green to green, and blue to blue in true color composite. But in this case, let's say we mapped a red channel to NIR channel. So in this case, we are not using red band at all, and instead of that, we are using the NIR. So as we know that NIR band is very sensitive to the vegetation. So here it makes sense because this red highlighted part is more vegetation. So it could be close to a river, it could be suitable for a vegetation, and it creates a very bright color composition if you use this band combination. So if you go to this link here, so it gives information on different combination of band. So let's say the natural color that we used was 432, and if we use 764, then it will highlight the urban feature more. If you use 543 as we use now, it will produce a color infrared composite, and it will highlight the vegetation feature. So even when we change this band sequence, then it will form different kind of a false color composite, and it will highlight one of the feature of the earth prominently. So if you want to know like if the band 5 is correlates to which, you can also see the information here. So currently we are using the Landsat 8. So if we use band 4, 3, 2, it was RGB, but if we are using 5, 4 and 3, it is NIR, red and green channel. Yeah, so this is the metadata that is provided by the satellite data provider. Okay, can you follow up to this step? Yeah, if you have any queries up to this point, please let me know. Can anyone update me on the chat? Yeah.
So we are up to the single band with visualization, NIR band, single band visualization, and then we did not follow you until the exercises.
Okay, so the first exercise is asking to extract from the image the spacecraft ID property, right?
Okay.
So to do that, we use this image.get function. So what it does is you can pass in the name of the property that you want to extract, and then this image is the image that we loaded earlier, right? That we are using. It comes from here actually earlier. From this step, right? So we are trying to get the spacecraft ID property of this image. So now this is a simple step where you can just I use image.get and then this spacecraft ID, and then this is assigned to this variable SPC ID, and then you can display this. So the spacecraft ID is Landsat 8 in this case. Yeah, is it clear?
Yes, it is clear.
Okay. In the second step, we are trying to create a false color composite. So the concept is that the true color composite is a more natural looking image, right? Like this. So that our eye also see. But sometimes if we want to highlight, let's say urban feature or vegetation, then we can use the combination of a different band. Our eye is only able to see RGB combination, but if we want to use NIR or let's say coastal aerosol or all those bands combination, then some of other feature will be highlighted more. When we use this false color composite, as I mentioned, 5, 4, and 3 in that order. So this 5 is instead of RGB, if we use 5, 4, 3, it is using NIR. I think what is the other two? Yeah, we are using NIR, red and green in order, that order. So it is not using red, green, and blue. Instead, NIR, red, and green. And so if we use that combination, 5, 4, 3, it will highlight the vegetation. Okay.
Okay.
So earlier, we can see the natural color image has this normal looking image, and I think it's surrounding the river area, and this area has a little bit more vegetation in compared to the other areas, and hence it is highlighting the vegetation area more prominently. So if there were some urban areas and you want to just visualize the urban area, you could use the combination of 764. Because the concept is that some of the this is the band is correlating with the electromagnetic radiation, right? That is reflected from the surface, and each of the object on Earth will have a different behavior to this wavelengths. So that is why the so let's say the leaves appear green, while other and that's why it is more sorry. Yeah, the object on the Earth will act differently to this bandwidth, and hence it will have a different properties. And when we use that combination, we can highlight some features on Earth more prominently. That is the basic concept of false color composite. Yeah, and if you see on the internet, okay. So you can create this kind of a very intensely highlighted map. So I think this one is also could be a vegetation, could be highlighting vegetation or some other feature, and yes, this one could be like a highlighting the urban areas more in this case. So these are the different combination of band to produce this result. So, but in our case, all of these extra features are like a not much vegetated area, so we can only see this feature being highlighted.
Excuse me, could you please paste these two codes of exercise in the chat?
These two?
Yes.
Yeah, sure. So this is for the exercise 1. And this is for exercise 2. Yeah, let me know if you face any issues. Okay, let's move to, I think, the next step. So then we'll complete the image part. So if you have image stored locally in your personal computer or in the cloud storage like AWS or Google Cloud Platform. So this image I am taking from Google Cloud Platform. You can also load that image. So in the earlier example, we just used data that is already available in Earth Engine catalog. But sometimes it can be required that you use your own data set. So here is a TIFF file because we don't have a data, so it's already available. One data was already available in the Google storage. It's like a remote storage. So I provide the URL here, and then if you use ee.image.loadgot function, and pass the path. So sometimes it could also be like your like this. So URI could be your personal storage, local storage, like C drive on your computer, right? Data folder, and then it could be data.tif. It could be in this format, and then when you use this URL in load.geotiff, then you can load the data. So this is the general step on how you can import your own data into Google Earth Engine. If I click run, then I can see this image has single band, and it is B0 unsigned integer, and you can also see other properties. Yeah, this yeah, you can try to paste this data and then see if you can load the data or not. It's available, I think, in the PDF. Yeah, this part. Yeah, can you follow up to this point?
So I have one small and basic questions. Question: what are we doing to extract with all this coding? I think I missed the initial opening speech of you.
So in you mean this part, the first
Yeah,
part?
until now we are following you up.
So the first step, so I'll show you the Word document, what we are going to do. Yeah, I think it will be steps thing. Yeah, so in the first part, we are working with the images. We are just trying to learn how we can import the dataset from Earth Engine catalog. Or in the last part, we saw how we can upload our own GeoTIFF. So, so we have a 4-day session. So when we import, this is a basic step on how we can start working with the images, basically. Yeah, and how to do visualization or extract the metadata information. All those things we learn in this step.
Okay.
Yeah, so yeah, let's say in the later part we'll do some mathematical operation on image, right? So we have to know how to do some basic operation, like how to select bands and all those things first. Yeah, that's why we are working on it.
So when we are extracting any other data from the metadata,
yeah,
we should follow the same coding, or we should use another coding?
We should follow the same approach. Let's say if you want to extract metadata properties, then you have to use image.get. Let's say here you want to extract the cloud cover, so you used image.get cloud cover, right? So in the later step in the exercise, you can see we wanted to extract spacecraft ID, so we used image.get spacecraft ID. So this is how you can extract the metadata information. But if you want to select individual band, then I saw you here, right? Image.select SRB5. So it means initially the band, the image has like 19 bands, but you only selected a single band from that image. So rest of the band you ignore. So this is how you can select. So if you want to select an individual band, you have to always follow this approach. Yeah.
For the rangeland and forestry, there is only greenery band for the greenery, right?
For rangeland and forestry, sometimes you have to use a band combination. That will depend upon your use case and methodology. Yeah, so let's say for tomorrow we are going to learn about surface water extraction, and for that we have to calculate some indices based on remote sensing indices like NDVI, EVI. So they will use a combination of band. Yeah. So even if you are trying to see the vegetation, then NDVI is useful. So in that case, you will use NIR and red band, right? So you'll just select the 2 band from the image. Yeah, is that clear?
Yeah, it is clear now.
Okay.
Wilson, we can take a break whenever it's convenient for you also, 15 minutes, huh?
Oh, I think already the time. So the first part is already complete. So maybe we can take a 15-minute break. But yeah, if you have any question, I'll be here. You can drop on chat or you can just unmute yourself. Yeah.
Could you please share the table of content in the chat as well? Because we do not have the table of content as you shared earlier.
Okay, I'll include that in the presentation that I shared.
Okay. Okay.
Let's have 15-minute break. Hello everyone. Yeah, so if everyone is here, then maybe we can start. Hello Safi, are you there? Hello, is anyone here?
بسبب شروط.
Listen, you are mute.
Oh, sorry, yeah, I was speaking. Okay, so yeah, let me repeat. Yeah, today is the first day of the Google Earth Engine training, and today we are going to do basic recap of Google Earth Engine only. And uh, it is today is the first day of the 4-day training. In the second day, we are going to do mapping surface water dynamics, and third day land cover mapping in Google Earth Engine, and last day is groundwater dynamics, mapping groundwater dynamics. So today we started with the basics of images, and we have already completed that, and the next step we will work with the image collection. So if I could know that if all of you are here, then maybe I could begin the next step. Anyone? Safi and team, are you there?
Yes, 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 we are there. Thank you.
Okay. Yeah. So yeah, we'll go back to our notebook and then work with the image collection. So as mentioned earlier, the image was a single image, but the image collections are organized set of images. So in Earth Engine, they are organized as image collection data type. So this is also a specialized data type that has specific operations available in Earth Engine API. So you can also do manipulation or analysis over the image collection directly. Okay, like individual images, they can also be viewed using map.add layer, right? So in this case, we can add all the image collection to our GE map, and hence we can visualize in the Jupyter notebook itself. So in this 2.1, we'll try to load the image collection. So again, I repeat that the previous one was the image and this one is the image collection. So it is a collection of an image, right? So this first step is we are going to get the rectangle or our area of interest where we want to download or where we want to view or do analysis over the satellite image. And in this second variable L8 call, we are taking Landsat 8 image collection, and previously we used ee.image, but in this case we use ee.image collection to grab the collection, right? And if we compare with the earlier one, this is taking the whole collection ID and not the individual image ID. And in this first step only, we are already giving the filter bound option. So what it is doing is instead of taking the Landsat collection for the whole world, it is only taking over our area of interest. So this is like a bounding box over which our this algorithm will try to search and confine the result, our result. So if you see display L8 call result, then you can see 474 elements will be loaded. Yeah, you can get this code from the PDF working with image collection, this first box here, load image collection data. Yeah, if you try to run this, you will get the information on image collection, the properties. So these are all the description and number of features. So you can see the image collection is as we mentioned is a set of images, right? So if you go inside image collection, you can see the list of features. So there are currently 474 elements that is filtered within our area of interest in this case. Yeah, so after we complete this, these are individual image IDs that is loaded into this collection in the first step. Okay, let's go to the next step. Now here we can see the Landsat 8 collection dot size. If we do this, it will give you how many images are loaded in the collection, in this L8 collection. Okay, here we went inside and checked the number, but it can also be directly checked by using the size function. Okay, if we run, it is same 474 images over our area of interest. And as earlier, we are defining the visualization properties, like we are trying to visualize a two color composite, band 4, 3 and 2, which is RGB, and visualize whole image collection, right? And let's load. Let's wait for a while because it is several images. I think we the image is overlapping over this area, and there are total of 474 images loaded in this particular area. If you zoom, you can see there are multiple images, right, being loaded here. Okay. So the next step is to filter from the image collection. We can apply different kind of filter, like filter date, or we can only select the first image over that list, and we can also apply cloud filter and all those things. So L8 call dot filter date, this command will filter over this time period. So we are even confining the result up to this date range. So if we run this script and then check the total number of images that is left after running this script, you can see the total number of images we receive after the cloud filter is 178. Yeah. You can try to run this script by using this PDF. Yeah, we've completed up to this point. And now we are working on this filter by date. Yeah, let me know if you have any issue running this or trying understanding this portion of the code. So there is this function available. So since this Landsat 8 collection is the list of image item, you can select the topmost item of the list by using this first command. So if you use L8 call underscore date dot first, it will give the first image of the list. So the data type is image, and the image ID is given here. Now we can visualize this image like in the earlier step. So we have filtered out only one image by using these functions. Let's say over our area of interest. So our area of interest might be somewhere around here, and only overlapping images will be displayed. First step. And second step is we have filtered by using date option. So all the images will be after 2020 to the end of 2023, collected between this time frame. And so from 400 something images, we have filtered it to 178 images, and we can apply other functions also here, right? So here we can also filter on cloud cover. This image has I mean, this area is very much covered by cloud. So to apply this cloud cover filter, I have some exercise, but you can also see the solution available here. This one. So what we do here, we apply this mathematical operation that we will see in the next step also. ee.filter dot auth engine filter, and this is less than command. So the less than cloud cover 20, it means the cloud cover should be less than 20 in our filtered result. So it is taking the collection and applying this this filter operation here. Okay, let's try this. Because previously we did not do any kind of a filter based on clouds. So we run this, you can see there are 152 images left now with cloud, that is less than 50%. Previously there were 178 images, and if the image has cloud more than 20%, it will be removed, eliminated. Yeah. So this solution is already available in this this part here, in this PDF in the end. Okay, so if you can follow, I can move to the next step, image mosaicing. Okay, so this in the image mosaicing part, the basic concept is that you have image swath. This is the individual image, and you want to combine all these images to form one continuous image over the surface. So mosaicing refers to the process of spatially assembling images to produce a spatially continuous image. It's like just connecting all those images together to form one continuous. So I'll try to explain this, what this code is doing. So I think it's available here also. Image mosaicing, yeah, this code block. I think you cannot copy this, so I'll just drop this code in the chat, because I think I pasted the image there in the PDF, so you cannot copy. Okay, here you can see that this is the area of interest or the geometry over which the filter has to be applied. So you can see this filter bound is applied in the next step, right? So this is coming from this AOI, or the area of interest. We take the Landsat 8 collection, and then we filter by date here. So the image is from 2021 10th to 2023 12, within this range, and filter bound will confine the result within our area of interest. So it is not giving the global result, but only within our area of interest. So if we run this code here, yeah, so you can see that before mosaic, the total size of the collection is 121. So these are the image that is going to be mosaic, and the mosaic operation can be done using this function here, lst8 collection, which is our image collection dot mosaic. So here the mosaic operation will be completed, and we select only one single band for display. So you can also display this whole mosaic if that is a requirement, but in this case we are selecting this mosaic and single band, NIR band, from here. So the new image type is lst8 collection and this NIR image, and then we try to visualize this NIR band here. So this forms completely a mosaic image. I mean, the image is stitched together. So in this case, if you want to check the image, change the image visualization parameters, yeah, to improve the contrast, you can just apply some some stretch, and the image contrast will improve like this. But this image is majorly covered by cloud, so it is unusable. in this case, because we did not apply any kind of a cloud filter here. So this step is the major step here. So because we are trying to do image mosaicing, Google Earth Engine also supports the mosaic operation. So you can run over the whole collection and it will do the mosaic. Right. Yeah. Can you run up to this point? Is there any issues that you noticed? Issues, okay. Yeah, so the next point is mapping over image collection. So this is a little complicated to understand in a sense that so let's say we have a function, let's say that will calculate the NDVI LST8 collection.
Can I ask a question here, please?
Yeah, sure.
So the first, if you mosaic, the images will be mosaic, but the bands will remain the same. For example, if it is the same image like Lancet 8. So we are only mosaicing the images.
We are mosaicing the whole images, all the bands. Yeah.
Okay. And also, if you have like, for example, this is from 2023, all the data is from Landsat 8. But if you have different data and we want to combine the bands, for example, for NDVI or any other one, so the bands are different. Then for each one, should we write a different code, like a separate code, or it will be one code with all those bands identified?
Yeah,
for example, please.
Yeah, so you mean combining from different sensors like Landsat or Sentinel, or
no, from the same Landsat but different version, Landsat 5, 6, 7, 8, like these. If you combine all these, for example, if I'm doing a historical analysis from 2000 up to now, so 2000 might be Landsat 5 or 6, and then we have Landsat 7, and then we have Landsat 8. Combining all these three, like the combining bands of all these three, will require a different code or separate code?
Actually, we do not. So in your case, if you want to see a long-term vegetation change, so you will create the annual composite of those for each years, right? So to see the changes between the year. So for each year, you will find the imagery from the same sensor. Let's say if you are using Landsat 8, then you can find from Landsat 8.
Okay.
Yeah, so there will be no issue in combining those images. But if you are combining between different sensors, let's say even Landsat 5 and Landsat 7, then the sensor characteristics are different, right? So previously, I think thematic mapper, and then now enhanced thematic mapper. So if the sensor characteristics is different, then you might need to have some additional step like data harmonization step.
Okay. Thank you.
Yeah, so Anis has asked a question, ST sort. So this will sort. So actually, when you do this Landsat 8 collection, this mosaic, then this is a collection of images. So the collection of images means the list of images, right? So if there is a, let's say 100 of images, then it has a different cloud cover. Then it will try to sort the images based on the cloud cover only. Yeah. So it is just sorting that list, and it is not doing the cloud filter in this case. Yeah, so if you have to do cloud cover, then you have to write additional cloud filter script that we did in the earlier exercise. Yeah, we did earlier, but I cannot find it now. Yeah, maybe later I'll this one here. Yeah, you have to use this command again, filter that cloud cover. Yeah. Cloud cover less than 20% in this case. Yeah, but this sort is only doing the sorting of that list. Okay, if it's clear, then we can go to this mapping over image collection. So the main concept is, let's say if you prepare a function that will calculate the NDVI, right? Then we will pass the image into it. Then the image will, the function will calculate the NDVI, and then it will give you the result. But if there are many images, let's say a 10 year of images for Landsat, then you will have let's say annual composite of each year, individual year. So in that case, you will have a list of images or an image collection, right? So if the map function will try to iterate over all these image collection and give you a list of output. So that is the whole concept. So if instead of running the code individually, it will run the code in whole image collection itself. So if you have any algorithm to run, then this map function will make it very convenient to run it over the whole collection. Yeah. So how to run this map function we will see in this step. Yeah, so the basic the step in selecting the image collection is same as before. We'll use the area of interest and then get the Landsat 8 image collection, and we use filter date to filter our date range and also filter bound over our area of interest. And this collection is sorted by cloud cover, and we will try to apply this define water detection algorithm. So what it will do is it will take an individual image from the collection, and yeah, we'll pass in image here, and then it will select only band 5, which is the NIR band, and that if the band is less than 10,000 here, then it will be true, and if it is greater than 10,000 it will be false. So it is trying to query less than or greater than. So if the values in the pixel is greater than 10,000, it will be 0 in the final output, right? So it is doing a simple thresholding algorithm. So it could so in this case we can in other cases we can replace this function with our more complicated function. Tomorrow we'll also see that our surface water mapping function will be complicated function in this case, but for the demonstration here I select a NIR band and apply a simple threshold. Okay, and if this function will only act on the image, but we have an image collection here. So what we can do is we can take this image collection lst8 call, and then we can use this map function, and then we can pass the function here. Okay, this function is this box here that will apply the algorithm to your data. So here you can see all the each individual image from the collection will go into this water detection algorithm, and the final result will be given back to this variable here lst8 call. Okay, so is this concept clear? Yeah, so and the next step is it is trying to get only the first band from here. So let's say this is the image collection, but from this image collection I am taking the first image. This first will if there is 100 of images, it will take the first one and then select the SRB5, which is the NIR band. We are only trying to visualize this one band here, and then this Landsat collection water one we are trying to visualize. So if we run this script, yeah, so you can see a binary map as a final result. So usually the result of this if you perform this binary this thresholding or using one particular point, then it will produce you a binary map. So like if it is less than 10,000 in this case, it is giving you the one value which is appearing bright in this case. So if the value is greater here, then it is giving you 0 in the final output, and hence the final output is darker pixel here. So it is not a grayscale but only 0 and 1. So this is the binary output map. So because the collection had large number of images, we just select the first one, which is also sorted based on the cloud filter here. Sorry, here, yeah, and then it is selected only the NIR band, because this input image will only take one NIR band. Yeah. So if you visualize, okay, yeah, I twist this code here. So yeah, I have pasted the code also in this in the chat. This is recently added, so I have not put in the PDF, or yeah, this I think it's the image one. Yeah. You can use this code to get this binary map. And so this is all about the image collection. So basically what we did was in the early step we tried to load the image collection from a Landsat image collection, and in the second step we tried to apply some filter like date and also cloud based filter and all those things. In the third step we did image stitching or mosaicing to combine all these smaller images to form one, and in the last step we did mapping over image collection. So if you are clear with working with this image collection, then I'll move to the next step. The third one is mathematical operations. Okay, so in the third part, the image math can be performed using operations like add, subtract, or complex computation with more than couple of terms. If there is more mathematical expression like a complex formula, then we use this expression function. So we'll use this basic mathematical function also, and also this expression in this part. So these are some of the basic mathematical operations that is available in Earth Engine. So if we want to perform, let's say, addition over the two images, we can use image1 dot add image2. So what it will do, it will add between the two layers and produce a third layer, right? Similarly, we can perform other mathematical operations like less than equal to, greater than equal to, like this. So the addition, subtraction, division we'll do in the NDVI part, which is after this. But here I'll try to explain this greater than code. Okay, so what it will do is in this part we will try to classify the DEM based on the elevation. Let's say if the data is greater than 1000 meter, then it will go to one class, and if the the digital elevation data is less than 1000 meter, then it goes to a class 2. So here we are loading the SRTM DEM from the image. It's not an image collection but an image. It is also from the Earth Engine asset, and this image has a many bands. So one of the band is elevation. So as seen earlier, we did select a single NIR band. Likewise, this one has an elevation band. So we use dem.select elevation, which will select only one band from that image. And we create an elevation mask, which means elevation is greater than 1000. So in this case, it will be true, which will be represented by one color. And if the elevation is less than 1000, it will create a binary mask. If it is less than 1000, in that case it will assign as 0. Okay, so that is our requirement, class 1 and class 2, and we will try to just visualize that on our library. But the visualization parameter is we have a minimum value of 0 and maximum value of 1, because it is thresholding, and we just have a 2 image on the map, and it is giving brown and green. So it means whenever the value is 0, it is assigning it brown, which is the lower elevation, and whenever the value is 1, it is assigning green. So this is the binary map that is produced as a result of this. So if you see a DEM, it is a continuous grayscale, but we just managed to apply a simple calculation over it. Yeah. And yeah, is it clear up to this point? Yeah, so even if you see this using this inspect command is available in this GE map library. So similar to in the Google Earth Engine platform. So if you use this I button here, you can click anywhere on the map to see the pixel information. Okay, let's see. Using this I, if I click here, it is elevation of 0, and if I click here, this is the elevation of 1, because we applied the threshold here, right? Greater than is 1 and less than is 0. Okay. In this way also you can see the pixel information. Okay, the next step is using the expression function to write a complex computation. Let's say instead of just greater than or less than, if you want to write this formula, NIR minus rate divided by NIR plus rate. So in this case, we have to apply some formulas. Yeah, we can do several classes also. Yeah, we can do several classes. I think I have done it here. In the exercise, I have given you 3 classes, for example. Okay, so here we load the image collection first, and we did filter bound by area of interest, only selecting image over our area of interest, and then we also applied the filter of the cloud filter, which it says cloud filter should be less than 10%, and there will be a list of images. So from there we only select first image in this first part, and in the second part we are trying to compute the NDVI, right? So we take image.expression. So instead of previously we did direct calculation like image.add, image.subtract, or image.greater than, those functions. But here we can write the complex expression inside this image.expression part. So our formula was inside bracket it's NIR minus read, which is this upper part, and in the denominator we have NIR plus read, this lower part, and we divide it. So but the image does not know what is the NIR band and read band. So in the, as a next parameter you will have to pass what the NIR band is. So here is where you will use the image.select in that we used in the first part of this tutorial. So we'll use image.select SR5. So the band 5, as we see also in this information, band 5 is the NIR band for Landsat 8, right? So using this information we can select NIR band. Similarly, the read band is SRB4, right? And then we rename the whole layer as NDVI. So each of the image band has its own name, like SRB5, SRB4, etc. So whenever this NDVI will be calculated, a new name will be based on this. So if I give NDVI underscore sample, the new name will become NDVI underscore sample, layer name. Okay, let's try to run this. Yeah, I think the calculation is done, and let's add the NDVI map for our area of interest. Okay, let's see. It's taking some time. Okay, it's in this area. Okay, depending upon our so this is the NDVI map that is generated for our selected image here, right? And yeah, as you can see, the NDVI value is less in this region, whereas surrounding the lake there is more NDVI. I think this is the river area where NDVI is less, more vegetation in this area. Yeah, we can interpret this result this way. Yeah, you can also apply a different palettes. So this color palette are available here. So depending upon your indices, yeah. So this
Excuse me, ours is empty. I don't know why NDVI tile is not shown in our case. It is run completed, but it doesn't show anything.
Yeah. So if you zoom out a little bit, it's around the Vietnam area.
Okay. We were looking for it in Afghanistan. Okay.
Yeah, I think the area of interest was around other areas. So,
Yeah, now it's visible. Thank you. Yeah.
Okay. Yeah, so this AOI parameter will do it all. So I think in the previous step we selected the AOI for Vietnam region, so that's why it's going to the Vietnam. So yeah, if you want to change the color palette, that you can also do from this GMap library using this. Let's try to report it. Instead of green, it's red. Okay, like this. Anyway, depending upon your index, you can apply different palettes. So by default, the green is selected here. Yeah. So the next step is this exercise where we want to do a threshold, a different threshold, right? So these are the range. So if the value is from -1 to 0 in NDVI, so it could be water, snow, or cloud. So you will assign it a class 1. And if it is from 0 to 0.2, it could be a barren land, build up area, or rocky area, and hence we assign it class 2. And if the vegetation, if the NDVI range is from 0.2 to 1, which is the maximum range, it can be classified as vegetation. Or similar kind of a classification you can also derive for different vegetations depending upon the range of NDVI. So here is a code because it's a little bit complicated to work in the first time. So so yeah, you can just copy this code in the hint, and the only thing you have to change is this value. Okay? So the logic is already written. So NDVI, where NDVI is less than, in our case it is minus, sorry, it's 0, right? So this value will be 0 in the first case. 0, then you assign the class as 1. If the value is less than 0.2, sorry, if it is greater than 0, but it is less than 0.2. So in this case, you want to apply class 2, and if the value is greater than or equal to 0.2, in this case apply class 3. So this is a logical, I mean, how you implement that logic in multiple classes. And if I try to add this layer, yeah, so it has a 3 classes now, only 3 classes. So if the vegetation is very high, in our case it becomes red. Yeah, if the vegetation is very low, it becomes blue, and if it is yeah, so depending upon this range, -1 to 0 will be represented as blue in our case. Up to 0.2 is green, and above 0.2 is red. Okay.
Excuse me, sir.
Yeah.
Mine is showing a little bit error. I'm following you up to the gmap.map code, and then when I'm doing the
in which part can you inform me?
Minimum 0, maximum 1, flat brown green, until that. And then when I'm doing NDVI, it shows an error.
This part, right?
Let me, yes.
Yeah, so just make sure that there is no extra spaces in front of your code, right?
Okay.
Okay, and then it should work, because yeah, you can also verify from here. So did this step work fine?
Visualization result work fine, I think. Visualization worked fine, and I have green and red map.
Okay.
But then the following NDVI step is not working, and it shows an error.
Yeah, or maybe you can share the screen and then we can check what is the error.
Okay. Let me share my screen.
Okay.
Yeah, this one.
This is working fine, right?
Yes, but here it's
okay. Yeah, I understood. As I mentioned, like when you do the copy pasting, sometimes this indentation can go wrong. So if you see in my case, the code has like alignment, right? So the spaces are not there. So it works in my case, but you have to remove the extra space. So let's say in front of dot image collection. Yeah.
Okay.
Can you go up? No, not there.
نوراني صاحب دا each pass image سره وې سره equal sign سره خپل جوړیږي هم دا هاي خیر او سره رن کا.
Yeah, and okay, now it will work fine. Yeah, next step.
Next step is
okay, now if you go to the Vietnam region, then it should show up. Yeah, it's there. Can you just pan your map to right? Yeah. Just click and move. Yeah. Right side.
right side, this way.
No,
United States.
left side. Yeah, down there. No, a little bit left.
Dar e India tarafta lași,
Anyway, it's there.
Çin tarafta. Çin tarafta lași, o Vietnam de maksat. Çin لاندې. همدغه د شین چې ښکاري د شین همدغه د زوم کې درته د زوم کې همدغه د روسي.
Okay, thank you.
Okay, let me move to the next part. Yeah. Okay, so the next part is a small part where we so after we do the analysis, we will export the data into
Sir,
our.
sorry, the individual, you copy the code for individual. Give you the individual you copied in third box. I run the same, but it gave error to me. I don't know why.
So error with the NDVI. Or
Yeah, individual classification. Please show me the code. I will copy from your.
yeah. So this one, right?
Oh, yeah. Okay.
So yeah, if you copy the code, sometimes the indentation, this space might be the issue.
Space.
Yeah, if you copy this, I have dropped the code in chat and it will work.
Okay. Okay, thank you.
Okay, so the next step is exporting the Google Earth Engine image. So after you do some analysis over the image, you can export the image into your Google Drive storage from where you can download, or you can also export it as a NumPy array. So the NumPy is a data type in in the Python. So it can help to manipulate the array data type. So basically the image is a type of a array, so it has in the X and Y column. So if you can get that image information as a NumPy array, you can do some additional processing over that data set. So in this step, we'll see how we can convert into a NumPy array and also how to save that into a GeoTIFF file. So the advantage of saving it as GeoTIFF is that when you download it from the Google Drive, then you can do some additional analysis in your desktop GIS software, or also create map using this GeoTIFF file. Yeah.
Excuse me, sir.
Yeah.
So we have until NDVI classification. So how can we interpret this data, this image? I mean, so we are now in an extraction stage, right?
Yes.
So we want to extract this data.
Okay.
Now we want to interpret this data, this image.
So let's say so that is why I give.
Can you scroll up? Can you scroll up?
Yeah. This map.
Oh, I have different colors of map.
Yeah. So it is in green currently, right? Yeah, let me make it green. So yeah, the interpretation is it's like this. So if there is the color is like a more deep color in greens, so it means the value is towards higher value, like 1, right? So it means higher vegetation. But if your value is towards 0 or negative side, then it is less vegetation, usually in case of the NDVI, right? So if you see here, the water body has relatively less vegetation, so it is appearing less greener than the surrounding area here.
Okay.
This is the basic interpretation. But if you have a class based on the threshold, let's say -0 to 1, if it is the NDVI range, so then for this area we have so it could mean water, snow, or cloud. Then you can also apply some threshold, additional threshold, using this second approach. Okay. So it will just make you this kind of map. So this currently is not a continuous, but it has 3 different color. So in our case, the blue is the least vegetation. So here you can see the blue is a river boundary, right? So it is less than 0 in our case, NDVI value. So all of these are classified as water bodies, right? So you can interpret it as a water body. So if you go to the green part here, so it can be
vegetation,
medium vegetation, yeah. Or if you go to the red, it is value greater than 0.2, so it is more vegetation. But if you have additional like classes, like if the value is greater than 0.7, let's say, in that case it is a dense vegetation, then you can add more classes. But this is just for demonstration, so I added 3 in this case. Yeah, in this way you can do the interpretation.
Then how we can calculate the area? I mean, it is dense vegetation or less vegetation.
You mean the total area over this surface?
Yeah, we are
Yeah.
over this image.
Yeah, so this is for the next step. So I applied some reducer and to calculate the population. So this is a very similar question that you asked. So it is coming up in the next step.
Okay.
Okay. Yeah. So yeah, for now let's first look into exporting the Google Earth Engine images. So as I mentioned, it can be exported as NumPy or the GeoTIFF. So here I load some error. Yeah. And if you run this code, then it will first take the digital elevation model from SRTM, and this is your area of interest, and get an array by masking. So it will mask out the digital elevation model by using this area of interest. So it means it will remove all our external extent, and actually this is getting the raster data here, but we want to compute the NumPy array, right? So the main part is this one, np.array. So it will convert this elevation data set that we get from this DEM raster to an NumPy array. So in this state. So if I have to explain this code, then it will take the band, the image from here, and it will get elevation band, and then it will convert that data type. Dot get info will always convert the Earth Engine data type into normal Python, and then it will convert that particular list into a NumPy array finally. So this is the overall step of converting raster image by using this get info and NumPy array function. Yeah. And now this dem underscore NOSHAQ, this area is I think this is a mountain area in Afghanistan. So if I plot this, I can plot this using the matplotlib library, which is a Python based library. Yeah, I can use plt.imso and then just display it. So you can see this is the highest elevation area, and the elevation is decreasing. So this is the Nosak mountain peak. So in this step, what we did, we imported an image and converted into a NumPy array that can be used in our program. But in second step, we will export this file as a GeoTIFF. So I will first load the image SRTM DEM, and I will select the elevation map. The elevation band only. So because it can have a multiple band in one image, so I only select the elevation. And then this ee.batch.export.image will export the image into to your Google Drive. So I am trying to filter the area of interest in Afghanistan region, and this scale is the pixel. The pixel resolution, like 30 meter per pixel is the output scale, and the name of the file should be DEM Afghanistan in this case. And then I can start this task using task.start. So if I run this, let's say, and you can go and check in our Google Drive. Okay, might take a while, but this is how it will be exported. DEM Afghanistan. I run it yesterday on December 17, but it will take some time to process, and it will appear in your list here. So in very similar way, I have also exported NDVI Afghanistan that we generated in the earlier step, like this. So that can also be exported, yeah, in a very same way. Instead of this elevation, if you use your NDVI map and replace it with the NDVI Afghanistan, it will export the NDVI map. Yeah. So any questions up to this point? No. Okay. So this is the fourth step where we try to export the data into different format. So now we are going into the last part of this training session. So it is vector data and chart. So until this point, we only use the raster data sets, but in this case, we'll also use the FAO admin layer as a vector data set to perform some operation over the raster data. Okay, so we have this population layer already available in the Earth Engine. So if I so similar to a Landsat image, this is also image collection data. So yeah, first I load this and I select first layer, first image from that, and if I print this data set, let's say display data set here, then it will give you all the information on data set, right? Yes. And the features, it has 5 different features, and by using this dataset.first, I am selecting only this one image from there. So which means it is a data for this, I think 2000, it is marked as 2000. The second was 2005, 10, 15, 20 likewise. And if I go to this first band also, there is first image also, there is multiple bands. So for in our case there is only one band. This is the band name. So in this case we select this particular band, so we reach up to this level actually. So from this image collection we selected the first image and the first band using this command, collection first select. Yeah, and if we display that population data here, then you can see this will be the final image. This image is same extracted from here. This and this are same. Okay, so this is the raster data set, which is the gridded population data set of the globe. And the second layer that we are loading is this feature collection. In all our previous step, we used image collection as our data type, so which would load raster data set into our system, into the variables. But if we use the feature collection, it will load the vector data set. So we use admin layer, and this level 1 will represent the country level save file, right? And inside it, so when we filter the admin 0 name to Afghanistan using this filter option, we will get only the Afghanistan layer here. So the second level will be the province level inside this Afghanistan layer. So we load the whole feature collection, the global data, and then we try to filter it only over the area of Afghanistan using this filter name, using this filter command. Yeah, and when you run this admin AF to see the data inside it, you can see all of them are this feature collection are the list of features, right? So as in the image collection it were list of images, in feature collection is list of feature. So there is currently 34 elements which will align to the provinces, and you can see in detail what each of the admin name it represents, this feature represents. The second feature, let's say it's Paktika. In the previous one it's coast, this way. Yeah, so we have already extracted 2 layers, right? So the first one is the global population layer, and the second one is the admin layer. And in this step I'll try to visualize both layers. So this is the global population and gridded population data, and this is the administrative layer that I extracted using the above code. So our end goal is to calculate the population for each of the provinces in Afghanistan. So for that, what we can do is it will apply a image reducer. So if let's say if this is an image and that we have to reduce, and if we apply some reducer function, so depending upon what the function is, the final output will be produced. So by that I mean if you want to take an average of all these data sets, then it will the reducer will give you average. If you use the sum reducer, then it will add all the pixel information and give you the final output as the sum of all the data set. Okay, so yeah, so using that raster and using the administrative layer available here, we'll calculate this reduced data set for each of the province, right? So yeah, this is the reducing algorithm that we are applying. This is also already available in Auth Engine. So population layer means coming from here, which is also the raster data set in the image here, the background image, and we use this reduce region function, and then there is this admin AF. So actually the documentation says that image.reduce region will take the collection, which is the feature collection, the feature to reduce over, which is in our case the administrative layer, and in the end what algorithm to apply. So we want to add all the population that is falling into that particular administrative area. So you want to use the ee.reducer.sum, which is going to add all the data set. So now if we apply this data, then you can see the output is same, like 34 features, but inside the properties now one additional attribute is added known as sum. So you can see there is 11 properties now. Previously there were only 10 properties. Features, yeah, only up to shape length 10 properties, but not sum. So once we calculate this, apply this reducer, it is also adding this sum data set. So in the next step, now you can see that all the province has the information on population, the sum of population. So the last step is to aggregate the result by admin one name, which means the province name in our case, which is showing in this x-axis, and the vertical, the data that is plotted is coming from the sum, this part here in our attribute table. And we use standard Python matplotlib library to plot this data in the end. So this is how we get the final output with the as a population sum for each provinces in Afghanistan. And very similarly, you can also plot if the background layer is, let's say, NDVI layer, then you can also calculate those applying some kind of a reducer, yeah, as someone asked before. So yeah, I think this is all for today. So if you have any questions up to this point, then yeah, please feel free.
Excuse me, sir. We are mine is again giving some minor errors.
Yeah.
It shows on the data set. Error is on the data set step 36, 35.
Yeah. So inside this vector data and charts, or
data set equal to EE image collection.
Can you read this title, heading title, or you can share your screen? Yeah.
Okay, I will share my screen. Can you see now?
Yeah. Okay, so yeah, so as I mentioned, this population count in the second line should move up. So can you go in front of population count? So in the second line, yeah, can you go ahead in the first? Yeah.
Okay.
Can you? Yeah. Now can you run it? Yeah. Now it will
That's
work.
good. And then I have the next step.
Yeah. Yeah. So when you copy paste, sometimes the issue with the pasting it. But later on, I'll share this notebook with you, so you can just try to run this notebook. So it will not have any issue.
Okay. One question from the image, we can calculate or we can find the population of each province.
Yeah.
So we can now we can find like animal head present in each province, or no, only population?
No, actually, so currently I use the population data set, right? So it depends upon if you have a data or not. So if you already have, you mean the animal head, right?
No, the number of animals. I mean, like number of animals in each province.
Yeah,
Livestock.
If you already have such kind of a data, let's say in this case we have a raster of population data set, right? So if you already have that data available, then yeah, you can calculate using similar approach. Yeah. Depending upon the availability of data, I'd say. No, can you go? That will be in next line.
Okay.
Remove the space. Yeah. Yeah, it's a work now.
Again.
Population. Can you go down?
Here?
No, I mean I want to see the error. Can you go down? Scroll down a bit. Oh, so can you go up and run the code in sequence? It cannot find some data. Yeah, from the top, 2-3 step above. Yeah, from the data set equals to image collection, we can try to run. Yeah, from there.
From here?
Yeah, also that one.
Remove.
Yeah, next step is also fine. Now add the order code block and it should work.
Visualize graded population.
Yeah.
It shows an error.
Can you scroll up a bit? Yeah, I'll paste the code. I cannot debug it from here. Can you try it? Yeah, it is in the chat. Can you use this? Just a second. Okay, now it will work.
Now this one?
Yeah, the second one.
The second one.
Yeah, admin L1. No, I think something is wrong with that one. So can you copy the code from chat?
Okay.
The second last code.
The second last.
Yeah. Right. Yeah. Okay, and the last one. Okay. Yeah, this one is just for the visualization, but for the chart there is one more line. Yeah. This one is the reducer, and last one is okay. There's two more code I have uploaded. You can check.
Okay. Okay.
Yeah.
Thank you.
Yeah. So anyone else, if you have any question, please feel free. Or you can also write in the chat. If not, maybe I think it's time. So maybe Lakman.
So one last question.
Yeah, sure.
All these codings, all these formulas are working similarly when we are extracting an image or data or NDVI. All these are same, or we shall go for editing or bring some changes?
So this is a basic introduction only. So if you, it depends upon your requirement. Yeah, sometimes you might need to perform some additional analysis. Then some of the module, yeah. So I have only covered a very basic part. So we have to refer to the documentation when we start to work on it. Yeah.
Okay.
So Sophie said it does not show the graph in the last. So
it's the graph is shown, but the map is not shown. I don't know. It runs It doesn't give any error, but the map that you are showing for Afghanistan, that is not shown in my.
So you mean the vector data set, right?
Yes.
Overlaid over the population. So yeah, maybe you can use the code I sent. Sometimes it can be issued with the PDF, you know. Yeah, and if it still does not work, then please let me know. Okay. Just make sure that if it is working fine, then you will get this this box in the earlier step also, right? So when you display the data set and population, if it is giving the error, then the error is already in the earlier step. So,
Now it works. With the last code that you copied into the chat box, this one works. Thank you. It works.
great. Okay, over to you, Lakmal. Yeah.
So we are done for today?
Yeah, we're done for today.
Okay, Hilson. Thank you. Thank you. It was very nice. It was very nice.
Thank you.
So tomorrow, I think Hilson will continue with the surface water mapping. And day after tomorrow, last day, we will do the land cover mapping and groundwater mapping. So I think that's the plan for coming 3 days. And if there's no more questions, we can start tomorrow again.
Sure. We will start tomorrow. We will practice on this. And if there is any question, we will ask you tomorrow morning, hopefully.
Perfect.
Thank you. Thank you, Lagman. Hilson, please.
Yusufi said one more question from Hilson. I mean, to start from the beginning, is there any learning materials or any site that we can learn from the beginning and go ahead?
Yeah, I can share with you some of the resources which you can refer to. Like I have some material like books and also some videos. Maybe I'll share with you.
Okay, okay, it will be nice of you.
Okay.